Now I'm going to talk about what is artificial intelligence. To start with, before explaining what is artificial intelligence, or before explaining even what we are trying to build, every industry they have some inherent problems. What are those problems? Right? For example, if I look at logistics and supply chain industry, it's about route optimizations. For example, what is the least cost movement of products from one location to other location? If it is online industry, let's say advertisement industry, how do I do a targeted campaign? How do I identify people who are interested in my product? Similarly, different industries, they have different problems. Now, the way to solve those problems is to gather intelligence. What is intelligence? Intelligence is about a kind of knowledge base that helps us in answering the problems. How do we build the knowledge base? There are two ways to build the knowledge base. One, manually. You'll write rules to predict or to classify, to recommend, or use the algorithms that are existing today. Right? Have you used this Titanic dataset for survival prediction? How many of you used? Good. How many features you have trained to predict the survival? So there are 11 features, right? How many features you have used to train the survival status?
So we have used 9 features like this, we will features, which is unnecessary to the model. Yeah.
Correct. Now, if I want to ask one question here, do families travel together has a better chance of survival? Families travel together, do they have a better chance of survival?
We'll be calculating whether he's traveled alone or not. We'll
Correct.
be creating a new future.
Yes.
So with that we have future like siblings, whether he will travel with siblings or children or not. With this will be create one new direction, whether he's alone or not. He traveled alone or not.
Yes.
So it plays a major role.
Good.
If he travels alone, he's less chance of getting sick.
Good, good. But here, I would like to add one more thing, the family definition. How do I get a family definition here?
Yeah, like if he has one sample, we'll be having future, already defined future, like he has siblings or not, or children or not.
Correct.
It is 0, 0, lab plus 1. So plus 1 in the sense, like we'll be creating a new future and will be, I will tell the beginning.
Okay, so I'll just add one more point here. The name of the customer,
Yeah.
or the name of the passenger here, have we included that as a feature?
Yeah, sure. We'll be taking the title from the name.
Okay.
Whether it's a Mr. or Mrs. or who.
Yes.
So with this, see, that is what we can do from the near future. The machine doesn't know if it is of the name Joseph, he is the machine doesn't understand.
Correct.
So what kind of guy is he? A girl or
Yes.
boy or married or not?
Yes. So, yes, why I'm taking this example is that now sometimes the question comes or the hypothesis comes directly, which requires further or application of a different level of intelligence. For example, in this case, if I want to use the passenger's name, I want to look at their surnames, the name, then the surnames are not standardized. I need to apply some pre-processing there. So to gather some intelligence, I have to do further processing on the data. So we need the help of NLP, natural language processing, to parse the text, correct the spellings, remove the white spaces, punctuations, standardize it, normalize the text, then do a match, get the family definition from the surnames, and match it with the other two columns.
So what does it do? So if you are telling them to get the survey, get the standard, what machine does understand with the help of this survey?
Correct.
If it doesn't know this guy with this guy that gets survey. So it is not like human way.
Exactly. We don't know like what kind of insight is there, we don't know. So, but we want to validate this hypothesis, whether it is true or false. If it is false, absolutely fine. If it gives some meaningful, it remains unexplored. So the objective here is whenever we are going for,
We are traveling like the guy who is surveying us, it will not see this guy is from having this surname, so he will survey you.
Exactly.
If this surname, it will survey this guy, not look at this.
Exactly. Exactly.
So survey everyone.
Yes.
So like how the machine will also do. We are
Yes.
seeing from the title, whether it's a girl or boy. That's just enough. We don't need to apply natural language processing over there.
Exactly.
This is the surname.
Exactly. So in this case, the hypothesis may not be true.
Yeah.
In this case, but there are some cases. For example, you are looking at, let's take the insurance data set.
Okay.
Right? You're looking at a claim processing here. Now you'll be looking at what type of vehicle it is.
Yeah. In that case, it's fine.
So the person who collects the data from the ground level, he reports it's Maruti Suzuki. If you ask people to write Maruti Suzuki, how many variants you will get?
Yeah. In that case, we can apply natural language processing to make it as a Maruti Suzuki.
Correct.
Yeah. That is fine.
So we need spell correction there.
Yeah.
We need natural language processing there to create features out of it.
Yeah.
Now, Maruti produces, let's take X variants of cars. Now, if I want to create a segmentation here, or to know that what type of cars are getting applying for more claims, is it sedan, hatchback, or premium? How do I know the classification? Because if someone writes Maruti Suzuki SX4, then I know that it's a premium sedan. But if somebody writes Maruti Suzuki only, I would not get to know that. But is there any way to get it?
No, that is what natural language processing.
No. Here, next step is, if I know that Maruti Suzuki only, the person is claiming that, okay, there is a scratch in my boot. Hatchback won't have boots.
Okay.
You need intelligence here.
Okay.
So here you will interpret that it's not a hatchback, it's a sedan. That's your artificial intelligence.
Okay, so how do you...
Exactly. So when you look at the description of the claim, the person says there is a scratch on my boot and he uploads a photograph.
Okay.
Without photograph, if you are looking the text, there is a scratch on the boot. Hatchbacks don't have the boots.
Yeah, but...
Brand name is Maruti Suzuki. So you will interpret that this is a sedan.
Yeah.
So like this, so artificial intelligence is about applying machine learning, natural language processing, and some kind of algorithms to arrive at a conclusion that the intelligence where it is not available, you will gather intelligence. Then you will pre-process it. This is just one example. There are many such examples. I'll come to the second example of where we will need artificial intelligence. Okay. Now, when you are looking at image processing, sometimes what happens, like when we are looking at various applications, it will ask you identify roads, identify a dog in the picture. You click, then it says that okay, I'm not a robot, right? How do you denoise one object from the background object? If a person is standing here and there is a green field outside, how do you denoise this object from the background object? It's an image classification problem. Okay. Now, first place here, how do we differentiate between background noise and with the object? You have to do a grayscale conversion. So this grayscale conversion that I'm talking about here, you need a couple of layers of convolution here to denoise the object from the background object. You'll see a variation in the pixels. There, you need artificial intelligence to identify there is one object and the pixel size is significantly different from the pixel size that you find in the background.
You use convolution networks to
Exactly.
like mini convolution.
Exactly. So you have to put a convolution layer between the object and the background. If you are mixing up this, you won't be able to classify further. That's what. Then coming back to language modeling. We have different languages, regional languages, vernacular languages, as well as English as a standard language. When we have multiple applications that accept inputs in different languages, we need someone to translate it so that we can standardize that in English or something to do or to perform some analysis. Currently, we do not have any translation. We need artificial intelligence to bring translation engines, right? So, anyone worked on translation, language modeling? Anyone worked on sequence to sequence? Sequence to sequence? Deep learning? Okay, I'll give you one background here. The sequence of sentences that we say, that determines the next sentence. We experience that in WhatsApp. We are typing, so it's predicting the next word that you would type. When you are unboxing a new smartphone, you are typing something in WhatsApp, it will not recommend anything. Right? You send a couple of messages, you start interacting with people, it gathers data. It's personalized. Then from your way of typing or writing text, it predicts that what is the next word you will be typing. It helps you in performing auto-completion. You want to quickly write few sentences, it helps you in printing the words. You have to just select from a couple of words which one you want. So that's one example. Now here, what is the algorithm? For example, someone asks me, hey, I heard that your daughter was not well, how is she now? My daughter was not well, now how is she now? The C is dependent on daughter, because that is a dependency token here, which means it's called sequence to sequence. The sequence C is dependent on the token daughter. So how do you model the sequence of a text that you are saying in a sentence? And is there any construct in it? Of course, yes. There is a dependency. There is a construct. There is a relation between different words when we say certain sentences. Can we model it? Of course, yes. Now here comes deep learning to the rescue. Right? So the sentiment analysis, I mean, everyone understands now sentiment analysis. What is sentiment analysis, right? How many unique ways you can do sentiment analysis? How accurate is sentiment analysis? Anyone done it, done any benchmarking on this? How good the classifiers are that are available right now on performing sentiments? So you have three libraries. These libraries are basically the text and the number attached to it. There are basically two ways you can do this computation. You'll attach a keyword and a number. Good, okay, +3. Best, +5. Worst, -5. So each token, you'll assign a number in a scale of -5 to +5. Now in a sentence, you will look for how many such words are present. You will just do a plus minus. If the net score is 0, it's a neutral. If net score is positive, it's a positive. That's how we do the sentiments. But really the words are independent of each other? No. I like product X, but not as like as product Y. Right? So there is a dependency here. The dependency are not taken care of when you are doing a sentiment analysis. I like coffee, but not as like as tea. Here, it's not about I like coffee. Right? So this kind of a complexity in the language, it's very difficult to figure out by applying the standard methods of doing sentiment analysis. Now, sentiment analysis is again how we are going to do it. We need artificial intelligence for that. Why? Here we say that for artificial intelligence, what we need is how do we build the knowledge? It's called building the intelligence or building the memory cell. How do we define memory cell? Have you worked on Keras? Anyone? Keras has a function called define your memory. The function itself called define memory. So that accepts multiple parameters from different models, different neural network models. So you feed in different neural network models, and each model uniquely, it performs certain activities. Now you combine certain activities and you put it in a memory. That's how you define a memory cell. That memory cell is basically building the knowledge. What is the knowledge? First step in artificial intelligence is to identify a problem statement that you want to solve. The problem statement could be solving the current level of sentiment scoring, predicting the fraud cases, predicting the online, let's take the hack cases, or could be understanding the unique patterns in the data. So identify a problem statement. Break the problem statement into multiple small projects or small tasks. Sometimes you will not have the Y variable or the target variable defined. You have to define the target variable, what you want to achieve. Then you just separate the problems into multiple small problems, then use the algorithm. That's how you will define the environment. What is the environment? The environment here is, I want to achieve better score in sentiment scoring. I want to identify more customers from my database. I want to understand the unique patterns, unique behaviors that exist in my customers' database. This could be your problem statement. This could be your environment. Who are the agents? The main agent that defines the entire role here, that plays the role of artificial intelligence is your robot. In Keras, the function I call it as a robot because you are defining the brain of a robot. You are asking the robot to take the input in a certain format, perform these activities and give the output in a certain format. It's a robot. That's how the robot is, right? It accepts input in a certain format, it performs certain tasks that is predefined, it gives the output in a certain format, right? That's how you will program the entire step. In artificial intelligence, when we are building knowledge base, it's a combination of various algorithms. You have to identify which algorithm does what. You define the problem statement, build a small algo there, and the output of the first algo can be input as input of the second algo. You can transfer it to different layers. Then, so first you have to give a structure to it. Identify the problem statement, create the environment, then define the task. When would you conclude that I have reached the target or I have reached the goal? The goal is to identify, let's take X percentage of new customers. If I am able to achieve that, I'm done. Till that time, I'll do the fine tuning. Right? Now, fine tuning as a human being, it's very difficult. There are so many hyperparameters. I can't just train it. I want the machine to train it. How do the machine train it? So you have to put everything in grid search. You define the set parameters, ask the machine to identify the best parameters from various grids. You do a grid search, extensive grid search here to find out the best parameters and put it in the final model. That's how the system learns. So here we are talking about building the ML algorithms. So the bunch of algorithms that we have, the family of algorithms that we have, that creates the memory of the bot. And it receives multiple inputs from different agents. It receives multiple inputs from different agents, but it knows like how to segregate the information, where to use, what to use. Now, you are the main person. You have to define which output, where it should go. Can I use it as an input in some other task, or should I just give it as a final output? That you have to decide, right? Is there any role for human intervention here? Yes. Machines can't do anything on its own. You have to first tell. Now you have to get the output and see whatever I asked, is it done? No, it's not. Then your input is required. You have to say what is expected, what is acceptable, what is not. You say that no, it's not acceptable. You fine tune it once again. Run another 20 epochs. Wait for the result. Then see the result again. So you are asking the machine to fine tune the results till the time you are getting the best result. So that's the objective of AI. You define the problem statement. If it requires single algo or single model to solve it, fine. If it is not, break the problem into multiple use cases or multiple problem statements. Use single algorithms at different stages, combine their results and use it. If it is not, then use a sequential. Take the output of one model, use it as input in the second model, then take it to third model, then fourth model, like this. It's called sequential modeling, right? So you have to understand the domain, the problem you are solving, the architecture. You have to look at the complete architecture, how the process will flow, where human intervention is required. Can the machine take this decision on my behalf? How do I define it? Right? So in machine learning now, so this is a very simple use case. So here we are not applying any advanced algorithms. It's a simple decision tree. The decision tree is looking at probably the humidity and temperature, and it says that whether it will rain or not. It's a very simple use case. It's clearly defined. But there are such complex use cases. There are some complex use cases where you need the machines to understand the granularity of the data, where the feature is not present. You have to extract features, right? So in AI, or while building this deep learning based models, what is important is feature creation. You have to spend 80% of your time on feature creation. Model building, you do not have to worry. 80% of your time should go for feature creation only. Right? So all of the competitions that you see online, day one, people jump into directly model. No. First 20 days of the competition you spend on feature creation. Why? Yes.
Peak processing is very important because when you have a raw data,
Yes.
so you have to do certain stages to come out of the missing value or the other parameters outline. So
Yes.
if you come out of that, then it is easy for understanding the data and do the model.
Absolutely, absolutely. So pre-processing here is very important. Sometimes what happens like the long range values, what is called like long range, for example, you are computing a distance between two timestamps and there is some mistake or some bug in the code, you'll get minus 14,000, minus 18,000. What's that? So for that, you need to understand the exploratory data analysis part. So EDA is mandatory. So first to get the data, you do the EDA. From EDA, you will identify those points. Why the distribution is going towards the left and why there is a negative point, such a large value. It could be there is some calculation mistake somewhere. So EDA will help you in getting corrected those things. And missing value, yes, identification is important, but imputation, that's the second step. Imputation, should I go for imputation or should not go? So you will create two variants. Create a model with imputation, create a model without imputation. Then put those two models together, ask the machine to identify which one is the best. So what is changing right now is that we are not defining the modeling framework. We are defining the problem statement and we are asking the machine to define the algo for us. So here the question is, when you are relying on one single model, this kind of problem will come. So for example, I have deployed, let's take a logistic regression model that is in production right now, and a new data set comes in, let's say last 15 days data comes in to my DB, and I want to refresh the model parameters and it's changing something. Because my model is not fitting to the data. So here I have defined the modeling framework. It is my logistic regression model. The data has to comply with the modeling framework, right? So what I'm talking about here is the reverse. I'll not define it's a logistic regression. It could be linear, it could be highly non-linear, it could be anything. So I have a family of models. The problem is a classification. So I have to first define the problem, whether it is a regression problem or a classification problem. It's a classification problem. So how many algorithms are there that can perform classification for me? So I have decision tree, random forest, support vector machine, neural network, then other bagging classifier, boosting classifier, etc. Now new data comes in. It says that, hey, this time the logistic regression model is not giving me great results. I'll switch to the wagging classifier because that's giving me best. How do we define the best? Of course, we can set the parameters, even like F1 score or accuracy or the AUC you can define. So, based on the performance criteria, it evaluates all the algorithms, the best one it takes. So, here the modeling framework is blank. It first identifies, the machine first identifies which one is the best, it takes that to production. So, your model always keeps changing. As your underlying data structure changes.
It's called as online learning, right?
Exactly. This is called online learning. So otherwise, your data, your machine will not learn from data. There is no learning. So in machine learning, without learning, there is no point. The machine has to learn automatically, right? So you can only monitor the accuracy parameters, the stability parameters, reliability parameters. Those parameters you can keep a track of. If it is every month, it is switching the models and it's selecting always, let's take logistic regression versus wagging classifier, there is something in those two models. The other models are not getting picked up. So why should I run other models? Why should I consume the cloud? Right? So I'll cut down the list of models. Initially, to the machine, I'll provide all 30 algorithms, okay, you train. Then over a couple of months, I will observe which models are giving me best results. That's how the machine learning comes into picture. So there is no manual intervention. So your human role would be here just to monitor the reliability, the stability parameters, how stable my accuracy is, how reliable my model is, how good my prediction is. If my prediction is not right, probably I can put few more parameters in the grid search mode to fine tune the results. Right? That's how. Okay. So in machine learning, or why machine learning? Because it's a very critical component of building the AI agents. AI, I'll call it as an agents. What are those agents? So agents I can define like, let's take I have my mailbox. I'm receiving so many emails. I want to classify whether it's a promotional email or it's a personalized email. Yeah.
I have one question. See, you said family of models. So you will have all the models in the system, and then it will choose the model based on the data.
Correct.
So it can switch from one model to another model.
Yes.
So in one project, example for a retail customer, okay, so the data I'm creating a model, I will create a multiple models and I will fit into the system, or one or two models I will be which is the best.
Correct. So it's called a pipeline. So you have to define a machine learning pipeline. So in the machine learning pipeline, what we'll call, like we typically use scikit-learn for that. So in scikit-learn, you have to define all those modeling parameters. Now, let's take decision tree, I'll define as a blank classifier without any fine-tuning parameters. So like this, I'll keep, let's say 30 different classifiers, I put it. Now all 30 will receive X-train and Y-train. X-train and Y-train is my cleaned data. So X-train and Y-train will go parallelly to all those models as an input. Then from each of the models, I will extract the F1 score or AUC. And I will train it in a cross-validation mode. So each model, I'll run it 10 times to see if the accuracy is changing or it's stable. I'll compute the mean accuracy and I'll compute the standard deviation of the accuracy. If the standard deviation is almost 0 up to 2 decimal places, that means my model is stable. If it is consistently giving me 90% accuracy with a standard deviation of 0.00, then it's probably the best model. So I have to look at two parameters, best accuracy and consistently it's giving me best accuracy. That's my best criteria. Then let's run all those models. 30 models will be running in the backend. The best will always come for prediction. Exactly. Initially you would need, but when you observe it over a period of time, 6 months you are only seeing the 2 models are coming good. The least, or from bottom, the 5 models you keep dropping. Next 6 months you drop another 5. Next 6 months you drop another 5. So when you cover it over like 2 years, you'll see that only 3 or 4 models are always giving me best result. Other models are either inconsistent or the accuracy is very less. They're not important for my data. In future, if you get a huge volume of data you want to experiment, just remove the comments, uncomment it, rerun the entire stuff once again. So the fundamental idea here is, let the machine define it. Why should we restrict it? The machine should see all the models. The best should automatically come. Right? Okay. Now, in this, if you look at the AI, when you are defining the AI engine or the robot or the brain of the robot, then first you have to define the tasks. Whether it is a supervised task, unsupervised task, or semi-supervised task. Supervised, if you know the outcome. In the training set, you know that there are 2 different outcomes. 0 and 1, true or false, accept or reject. There are 2 defined outcomes, or 3 defined outcomes, or 5 defined outcomes. If I know that there is no pattern here, there is no outcome, still I want to get some outcome from this, I'll use the unsupervised learning. In using unsupervised, I'll get some labels, I'll ask the user, you say which one is making sense, which one is not. Then once the user validates that, that becomes my label. Then you train the algo once again, then predict. Right? So, the last part is the reinforcement learning. The reinforcement learning, it's basically a chatbot operation where you are penalizing a wrong decision, you are giving reward to a correct decision. What is a correct decision? What is a incorrect decision? For example, you are accepting or you are granting loan to someone who has a low credit score versus you are rejecting someone who is having a high credit score. Right? So in those two cases, I'll just introduce the reinforcement learning stuff here. So there is an agent, there is a policy, there is a reward, and there is a penalty. So the policy is basically my function. It can be a linear function, it can be a non-linear function, it can be any kind of transform functions. There are a bunch of functions. Right? So I'll use a function to predict or to classify something. I'll show it to the user or the agent. Ask the user to verify whether it is making sense or not. You say, no, this is wrong. Okay, why? Because so and so things. Now you decide, okay, this is a critical criteria. If my model is not predicting the thing correctly because of this critical criteria, I have to double penalize this. You said that, okay, penalized times 2. Next time this comes, the weight will be reduced by 2 times. In a neural network setup, when we are dividing all the weights by 2, anytime, anyways, it is reducing the weightage. The prediction weightage, it is reducing. If you want to introduce a reward, increase the weights by a fraction. You say like 20% increment to the existing weights in the neural network. You are giving reward to a correct decision. You are giving the penalty to the wrong decision. Now you identified, let's say 2 critical parameters are like feature 1 and feature 2. Now from feature 1 and feature 2, whatever weights are getting generated to the hidden layer, I'll reduce the weights by half. They are losing importance to the next layer of prediction. Correct? But if I want to give a reward, I'll increase the weights for a certain feature. So it's very important to know that which features weight has to be reduced, which features weight has to be increased in terms of reward and penalty. To know that, first I have to display to the user. I'll say that, okay, you say which one is good, which one is bad. So that's part of your reinforcement learning. It is helpful in chatbot. It is helpful in natural language processing. It's almost like in next 5 to 10 years, this is my personal observation, next 5 to 10 years, reinforcement learning will be the norm. Supervised, unsupervised is going to be a pre-processing step. Everywhere you will see reinforcement learning in practice. That's going to be now because everyone wants to do, like everyone wants to teach someone. Like you can teach a robot, you can teach a computer, you can teach a program. You are trying to teach something and you want the agent to perform the task accurately. The agent should classify or predict or whatever task you are assigning, it should do automatically. Right? Exactly. So reinforcement learning is the main engine behind AI. Okay, fine. Now deep learning, it's like when the machine learning problem becomes little complex, then you need deep learning. Why? So the same example I'm talking about, when a new data set comes in, now you are relying on multiple different models and you are asking, you fit one model to the data and tell me how the accuracy is. Right? But if there's a sequence to it, I can't do this using one model. Whether it is decision tree or gradient boosting or maybe a logistic regression, I can't rely on one model only. I want to apply the second model on the results of the first model. I need different functions here. Linear, hyperbolic tangent, sigmoid, softmax, RBF. I need 5 different functions to define. Here, in deep learning, I don't want to explain the model. I want to predict or classify things correctly. When model explainability matters, we should go for machine learning. When prediction or accuracy is very important rather than explaining. If you can identify one fraudulent transaction, you are good enough. You don't need to explain it. If you are using deep learning to predict the fraud cases correctly and you are giving more accuracy, and you are not able to explain the deep learning model, it's still fine. There are some use cases where accuracy matters. It's not about you are explaining the model to someone. Like self-driving cars. You have a 360-degree camera. The camera is doing a projection to identify the objects in the route. So the camera prepares the hyperplanes. Like 360-degree, you are creating hyperplanes. In those hyperplanes, you are trying to understand what object is there. You are doing first object recognition in this hyperplane. Then you are predicting the proximity using ladder. Ladder says that how distant is the object and what is your speed, what is the event time. Based on the event time, it asks the machine to take a diversion. Object recognition, this is one.
How do you find the object recognition?
Ladder.
You see a panel like Acadgild.
Yes.
There are two panels like Acadgild and
Yes.
How the machine will come to know that's a word for Acadgild in that banner? So if I wear a t-shirt with the name Acadgild, how the machine will differentiate this is the place where it's a banner called Acadgild, and there is one person who is wearing t-shirt with the name called Acadgild.
Yeah, it depends on the trainings. It depends on the training set.
No, like you will see the pixels and it will
Exactly.
know it is the banner with the man.
Exactly. So it has to be labeled properly. So your training data has to be correctly labeled. So when you are always saying that, okay, it is written on my t-shirt, and you are saying that it's a human, and it's written on the board, okay, it's a wall.
Both the t-shirt
Exactly.
and the banner are separate.
Exactly.
So if there is a no competition as a grade, suppose only a man is standing with the t-shirt named as a grade, so machine will start saying that okay, there's a competitor as a grade.
Correct.
That will recognize that way.
Yes.
But there's no competing on attitude that way. Only there is a person wearing a t-shirt with the name called
It depends on the training set. It depends on the training set. When you look at, let's take face recognition when you are setting up in your smartphone.
Okay.
You are giving how many times, how many addresses? Like 10 samples you are giving, 10 times you are showing the face, it should recognize the face. If you close your eyes, the person is sleeping. It should not open the camera, right?
Yeah, the machine will come to know it is a face.
So it requires more training. It requires more training.
Okay.
So machines are right now, whatever performance or whatever accuracy it's giving right now, it depends on the existing training set. The training set has to be curated further. Training set labels should be done properly to improve the process better.
So we recently have a Google assistant called Google Lens. Suppose we give a photo to the Google Lens, it will telling us, so this is this product, this is this product. So I'm asking how it is recognizing that.
Because they have good training data. They have massive training data. That's the advantage they have.
Okay.
So when you want to build such kind of system, you need to have training. Now, when Professor Andrew MG, he started recognizing the cat is a cat. He collected almost like more than 1 million images. Okay. And he labeled it. And he trained on 10,000 cores to make a correct prediction the cat is a cat. So it takes time to build the labeled dataset correctly, to build a good training dataset. That is very important for any machine learning task.
But everything is the pixels.
Correct.
Everything is the pixels.
It's pixels. You can do a small experiment also. So you can take photographs from different angles, store it in a drive, use scikit-learn, parse the images, create you create just an array in your Jupyter notebook.
Yeah.
Then you upload one more photograph of yours, ask the machine to predict.
Okay.
100 samples, it will work. So you need a good training data set to make correct classifications. Similarly, whether the person is wearing a t-shirt or a standee is just wearing this t-shirt, how do you differentiate those two? So basically, you have to differentiate living objects versus the standing objects or something. You have to differentiate that. Now there has to be a correct labeling. So if you put a label, okay, this is human, this is not human, as a label. So in a layered prediction, first you identify human.
It is always confused, right?
It's not if it is not trained properly. Two things. One is correct labeling or the training set, sufficient training set, and feedback. That is important. Okay. So this deep learning is not new. So it's basically coming from the human brain. So it's why? Because sometimes We do not remember the connections, the weights, but there is something hidden which helps us in recognizing. For example, you are seeing your school friend after 17 years or 18 years. You will try to establish a connection. Somewhere I have seen this person. Somewhere I have seen this person. It takes maximum like 5-10 seconds or probably 1 minute to identify the person. Because human brain is super powerful. We know that. But while mimicking the same system here, we need to establish a lot of connections. Those connections are nothing but the weights. Here the weights currently it's a random. Right? So the next evolution is happening around how do we allocate the weights to the deep learning layers. How do we regulate the weights? Sometimes you see that, okay, neural network models gives us like a very overfitting results. That's not permanent. It's a stage. It's going to the next stage now. The next stage will be, the research is happening, so the next stage will be, how do we regulate the weights? How do we cure the overfitting? It's a journey. So AI revolution or the deep learning revolution that is happening, the changes that is happening right now is just the beginning. It will take time, and like many things are happening now. Language modeling, natural language processing, deep learning for natural language processing, object recognition, sensor recognition, audio recognition, many things are happening. Now, each and every technique, it's not permanent. The loopholes that you are seeing, the defects that you are seeing in the algorithms, it is only temporary. Research is happening around that to improve it further and to take it to the next level. Many more algorithms will come in future. Like if you see, there is one more algorithm, it's called FTRL, follow the regularized leader. It's a different algorithm altogether. So there are, like in neural network or deep learning, the algorithms like autoencoders. Autoencoders will remove the role of PCA that traditionally we use to identify the principal components in a data set. Now this autoencoder it's only one variant. There are variational autoencoders. There are different variants of autoencoders. Now it's just evolving. Many such techniques, many such algorithms will determine like what is right, what is wrong. And when you are not sure about something, put everything right. Put everything in one place, decide a criteria, and allow some time. Let the machine identify the best one. Then over a period of time, you observe that what is happening, why these algorithms are not working in this case, why these are working in this case. Then do a selection from that. So that's how you start. Yeah. So this is just an example of one of the LSTM. So how do you build the LSTM cell? So in LSTM, what is happening? Like sequence to sequence. It remembers the sequence of text. It predicts the next sequence of text. So in LSTM, you have to define the memory cell. So it's going like one step deeper into understanding how the deep learning networks work. In deep learning, there are 3 different variants which is popular right now: DNN, CNN, and RNN. DNN is your deep learning or deep neural network, where you have more than 2 hidden layers. So there are 2 variants, deep and wide. Wide means you are giving more hidden layers. That is also a variant of deep learning. You are giving more neurons in each hidden layer. That is, you are increasing the depth of the deep learning model. So this is called deep, this is called wide. Both are called deep learning models or DNN architecture. CNN is basically your convolutional layers. You have pixels. You want to reduce it and represent it in a smaller dimension. Then you have to convolute and compute the important things from the convolutional layer, take it to the next layer. That's your CNN. RNN is part of your sequence to sequence predictions. It's called recurrent neural network. From one sequence, it predicts the next sequence. That's how it proceeds.
And also will have convolution layer.
Convolution is specific to CNN. Because you want to convolute, you want to get a convolute feature because you have something called, it's called stride. So when you have an image, and so there is something called mirror. Let's say this is one image. In the image, first I have to look at the slide. The slide means I have to decide which pixels I want to target.
So for that you use control. So
Correct.
which is
Because
we have a
exactly.
picture, we see the tile. So here where the tile is there for a tile.
Exactly.
So what is happening in RNN recurrence? Like
In RNN, no. In RNN, what is happening? Okay, in standard deep learning architecture, you have input, hidden 1, hidden 2. Then I have output. From input to hidden 1, I have one function.
Okay.
From hidden 1 to hidden 2, another function. From hidden 2 to output, another function. I have activation functions.
Okay.
Right? Now, first set of weight, let's take input to the hidden layer 1. All the weights, I will call it U.
Okay.
Hidden 1 to hidden 2, I will call it V. And hidden 2 to output, I'll say, let's take X. These are my weights I'm connecting. But if there is any connection between H1, neuron 1 to neuron 2,
Depends on the weights.
I'm not passing anything here. I'm passing this way. Within the hidden layer itself, from neuron to neuron that transfer, I'm not doing anything here. There is a state transfer here. Within the hidden state itself, I'll define another set of weights, which will determine the current state is a function of the previous state. The classic case is the stock market predictions. The stock prices. Today's stock price depends on the yesterday's stock price or probably last 2 weeks' stock price. That I don't know.
So like transfer layer.
Exactly.
So you will get the weight, you will learn the weight, so you will use that weight next day.
Exactly.
Previous weight.
Exactly. So your hidden state.
So like it's both online learning, transfer learning, like online learning kind of like we are
Correct.
from
Here-
day to day we are learning from the previous weight.
Exactly. So here, in the hidden state itself, you are going back and forth
Okay.
to fine tune the weights before producing it to the final output layer.
Okay.
You are not reaching to the last layer till the time you are done with this layer. So you are defining multiple neurons here, and you can decide the cell. LSTM cell, suppose I'll say 5 or 3 or 2 or 10, I can define this. So within this layer itself, the hidden layer itself, it keeps on moving. And if you can define till how long you want the LSTM cell to remember the node. If I want the information to become redundant after, let's take 3 iterations or 5 iterations, or you want to retain it for 100 iterations, that you can define. That's your LSTM, long short-term memory. You can define till how long you want your algorithm to remember this cell. Then you can regulate the exit gate to determine till how long you want this memory or information to be stored. Whenever you don't want, just define, okay, after this time, remove this.
Remove this in the sense you will
Remove the information means drop the weight. You are dropping the weight means there is no connection here.
So you start learning from the new random.
No, because the state has already been transferred.
Okay.
You don't need this information anymore.
Okay.
Then you don't want to get a connection here. If there is a connection, there is some computation. It increases the computational cost as well. When you don't want something, you drop it. So then there is no connection here.
Drop is just drop weights.
Drop weights. That's called setting the dropout rate. In the deep learning, when you define the dropout rate, see, when certain features are not connected to the hidden layers, there is no point in keeping the weights because ultimately it's only matrix multiplication happening. Why to compute?
So you will remove that layer. So if you have 4 hidden layers,
Layer will not be removed. The MLP will be removed. The multi-layer perceptron. Suppose in hidden layer 1, I have 5 neurons.
okay.
2 of them are not getting any signal.
So you will reform the weights, right? So we will
Exactly.
be 5 weights, 3 weights each. So
Exactly.
you know, 2 neurons are not hidden now.
Yes.
So you are removing 2 neurons from one hidden layer.
Neurons are there. The weights I am removing.
So okay, 2 weights. So we are having 5 weights now. So
Yeah.
2 weights you are removing.
Yes.
So
Because that restricts the model from overfitting.
okay.
So there is a theory behind it, why it is happening. And basically, when you are using this in, let's take in image processing, you would not definitely remove any weights. Dropout rate you will not apply. When you are using this for structured data, you will use it.
So like you make this 0 that weight.
Yes. No, you will not make it 0. If the weight is 0.5, you can't make it 0. You will set only those weights which are less than 20%. Only remove them. It's a conditional delete. The removing is not random. Removing is based on certain conditions. So if a weight value is 0.001, that's 0.
Like if we have a filter that is nowhere correlating with our,
why would I keep it? Exactly. That's what we're doing. So that's how you'll set this weights. The next level is basically, again, in LSTM cell, how do you, do a weight initialization? How do you trigger the weights? The weights are currently it's random. It has to be from a distribution, hence you need statistics. Which type of statistical distribution generates random weights? Similar to the features. So you will generate only features, you generate only weights from the relevant features, and that is random. So it's called the theory of a weight initialization in deep learning. So like many more things are there. So LSTM is completely different from CNN. Yeah, so that's the difference between, so for performing any AI related task, if the task is simple, then you will be using machine learning. If the task is complex, you will go for deep learning. When the objective is to get more accurate results, sometimes what happens, you have a training set, the target is 0 and 1. Ones is something that you want to predict, which is 2% only. You have 20 lakh records. Only 2% of them are ones, the rest all zeros. It's very difficult to predict. Very difficult to predict. And if you compute the accuracy, it will give you 90% accuracy. But it will not predict the 2%. It will predict the zeros. You need now deep learning in this. So till the time X percentage of the target is not achieved, you keep fine-tuning the parameters and keep running the model. That's how you need deep learning. Standard algorithms will not help in predicting the rare cases. So when the problem becomes complex, you need deep learning. When the problem is simple, you will be using machine learning. That's the clear differentiation. But overall, for any kind of AI related task, you need those two. Either you'll go for a deep learning or you go for a machine learning.
Acadgild. Average is dead.